The history of the Reynolds number started in the 1840s when Sir George Stokes researched viscosity and his development of the Navier-Stokes equation. It wasn't until 1883, however, that Osborne Reynolds developed the first visual representation of the phenomenon using his device here. Using water and dye, he represented the transition of flow from laminar to transitional to turbulent. And this ratio of inertial to viscous forces he coined as K. It wasn't until 1908 that Arnold Sommerfeld quoted in his paper, "R is a pure number, we'll call it the Reynolds number," where he coined the term as we know it today.
He described his number, the Reynolds number, to be the inertial force over the viscous force, which is equal to the diameter of the given pipe in meters times its average velocity times the density of the flow divided by its viscous force, as you can see here. He described any sort of laminar flow where his Reynolds number was below 2100, laminar flow being where a particle in one layer will stay in that layer as it flows through the pipe, to be the laminar flow. Anything between 2100 and 4000s to be a transitional flow, which will exhibit both laminar flow characteristics and turbulent flow characteristics, and specifically turbulent flow being any Reynolds number over 4000, turbulent flow occurring at much higher velocities, and it results in eddies and vortices and mixing of the fluid within the pipe.
Hi, I will be showing the application of Reynolds number using this spray bottle that I stole from the janitor's car. When I first pull the trigger, it will be laminar flow up until it hits the window, and then it will be turbulent. So when I first spray, it hits the window and then the fluid spreads out in all directions, shown here. Okay. Make sure to clean up afterwards.
For example, here we have a Newtonian fluid with a viscosity of 0.38 newton-seconds per meter squared and the diameter of the pipe being 0.025 meters with a density of 910 kilograms per meter cubed and an average velocity of 2.6 meters per second. So here we have our givens, and we would plug this back into the Reynolds number equation, which is the diameter times the velocity times the density all over the viscous constant. So we plug in all four of these numbers, and we get 156 kilograms times meter all over second squared all over newtons, which is a unitless number. So we get 156, which is less than 2100, so therefore we have laminar flow.